Zoom page width view full screen. Okay, so Sarah, for you. A. Derivative of 2 sine x plus 6x power minus 9.
Where's the y beside this d?
Where's the y? Ah, this is the confusion. I understand. I understand perfectly now. That whole thing in brackets is the y. So, like, for example, if I said
So
dy...
all of this divided by dx?
No. Oh, I understand the confusion. Yes. This here means calculate the derivative of what's on the inside. So I just use, in other words, use my rules for all of this piece on the inside. That's all it means. So the point of number 2 is partly to show you all the different notation. So here it just means the regular derivative using the rule. So what's the derivative of sine?
Cosine.
Cos, yeah. And then what do I do here? I bring down the power. And then I take 1 from the power. And it's finished. Yeah? Alright, I'll do B now. So B, so you need me to go back?
Yeah.
Yes. 2A.
Okay.
All good? Okay. Who could that be? Yes?
Can we disturb you?
Sure.
Okay. I have a couple of students from last year here.
Ah.
They're currently in DCU. They'd like to say hello, and they'd like to have a word with the...
Okay. So, do you remember earlier in the semester we looked at finding the minimum point on a quadratic? What technique did we use to do that? Actually, I'll have that tissue to clean it if you still got it. So what technique did we use to find the minimum point on a quadratic? Thank you. Like if I said there's a quadratic, find the minimum point, what would you have to do first? What's the name of it? The technique? No? Oh, come on. Somebody must remember.
You and me.
Guys, come on. Seriously, somebody must remember. If I want to find the minimum point on this quadratic, so like,
Completing the square.
yeah, completing the square. Remember? So that's fine if it's quadratic, but of course if it's cubic or something else, you can't do this. But what you'll notice is that if I draw a tangent line at the minimum point, there's something special about the value of its slope. What's the value of its slope here? 0. So actually, the same thing happens at the top as well. That the derivative, the slope of the tangent is also 0. So this kind of gives us our rule for this lesson. That if you want to find the max or min, all you need to solve is the equation dy dx equals 0. This will give you the max or min points. They also go by other names such as turning points or extreme points. So I'll just call them turning points because that's most common.
Do they also call them pivots, or is that just...
No, I don't think so. No. Okay. So let's take an example with a quadratic then. So here's my quadratic, and I would like to find the turning point, the minimum point here. Now, how many turning points should it have if you picture the graph? How many places does it have a minimum or a maximum?
Wait, for a quadratic?
For a quadratic, for this quadratic? One, yeah. So if I calculate the derivative, what's the derivative here? 2x plus 1 equals 0. So x equals minus a half. Okay? And then if I want to find the y, I just take this result and put it back in here. And I get y equals a quarter minus a half is minus a quarter plus 1, so it's 3/4. So there you go. That is the point where the minimum takes place. And that's
3/4? First one?
3/4 is the y, yeah. So if I draw this, I know where the minimum is. Yeah? Let's do an example with a cubic. So if I say y equals x cubed plus x squared plus x plus 1. If you picture the graph of this, how many turning points should it have?
2.
Yeah, it should have 2, shouldn't it? So if I calculate the derivative, there's the slope of the tangent there. It'll be 3x squared plus 2x plus 1, and you need this to equal 0. So mode 53 on your calculator, tell me the two answers you get. Come on.
This root.
Yes? Come on, please. Mode 53, I want the solution to this quadratic. Doesn't matter what mode it's in for this.
Is that 2?
It is.
It's
A decimal is fine.
no, it's not even.
No, it's
It's square root and a fraction.
Yeah, so just press the SD button to give me as a decimal, yeah?
It's
it gives us something with an I at
minus
the end.
0.333 plus 0.47.
Okay. Dang. I picked a bad example. Alright, well I'll take one from the book. So I'll do number... Yeah. I'll do number 1 actually, since it's a cubic. So number 1. Y equals 2x cubed minus 6x squared plus 6x minus 6. Okay, so who can tell me what the slope of the tangent is here? What will it be? 6x squared minus 12x plus 6. Now, I'll use this here. So you want this to equal 0. 6 minus 12, 6. So I got just one answer here actually. I got x equals 1. And so y would equal 2 minus 6 is minus 4, minus 10, minus 4 is it? Yeah. Now why does, we talked cubic has 2 turning points. Why does this cubic only have 1 turning point? Well, we can use derive to draw it and we can see what happens. But when I say a cubic has 2 turning points, it's like saying a cubic has 2 roots or 3 roots. It can have up to 2 turning points, you know? Like how many roots does a cubic could have? How many roots could a cubic have? It could have 3 or 2 or 1. But what about a quadratic? It could be 2, 1 or 0. Same goes for turning points. You could have 2 turning points or you could have just 1 turning point. But you should always have a point. So can you just read out the quadratic, the cubic? What was it? Y equals
2x cubed minus 6x
2x cubed minus 6x squared.
plus 6x minus 6.
Okay. Now let's look at the turning point on the graph here. So where was the turning point? 1 and minus 3?
1 and minus 4.
Okay, so I'll zoom out. Not zoom out. See how it is here? Okay, this is the where the tangent line. Can you imagine the tangent line here? How it would be horizontal? Now let's have a look at another one now. I'll leave derive open. So I did a cubic, but I want to do a cubic that has 2 answers. So that's actually number 2 here. So y equals 2x cubed minus 9x squared minus 24x plus 30. So that'd be 6x squared minus 18x minus 24, and that should equal 0. So if we get the solutions here, so what are the two values for x here? 4 and minus 1 are the two values for x. Yeah? Do you all get that?
Yeah.
And how can I get the y? By subbing it back in. So the 4 is minus 82, and then the minus 1 turns out to be minus 92. So there's our cubic, and we found the two places where the tangent slope is 0.
So how did we get
Yeah.
minus 92?
I put x as minus 1 into the original to get the y. Original, because this is a formula for y, isn't it? Y equals this thing. So if I know the x, I just plug it back in here, it gives me the y. Now I'll plot this in derive. Can I? No? Right, so let me look at this one. I'll go back to it now in a minute. Can you just read it out to me? What is it? Y equals 2x cubed
Minus 9x squared minus 24x plus 30.
Okay. Let me get rid of that. There. Reset. Draw. Now I'll have to zoom out because the numbers were large. So. Whoops. Almost got it. Now, what was the first turning point?
4 and minus 82.
4 and minus.
18.
Now, if you look here, would you say that's roughly what you expect? 4 and minus 82, you said? You can see there that it's roughly going to be that. So let me rub that in. 4 and minus 82. Okay, and then what was the other one?
Minus 1 and minus 92.
Minus 1 and...
Minus 92.
Oh, I must have the wrong sign there. It must be positive 92. Can somebody put in...
43.
Should be 43, and that looks about right. Thank you. So it's minus 1 and 43.
Supposed to be plus 9?
No, it should be 43.
No, I mean the original. Okay.
Ah, okay. Plus 30, yeah. Okay. So you see what's happening here? We're using the derivative to find these turning points, the part where it turns. Now I'll do one more, but I'll do the third one, which is log. Do you need to write that down, or can I do the log one? Yeah. Okay, so y equals log x 16 minus 9x squared, sorry, no, plus 2x squared
16x
minus 16x minus 5. Okay, so you want the derivative here to be 0, so before I can calculate the derivative, what should I do with this power? I should move it in front. Now I'll get the derivative. So what's the derivative here? What's the derivative of log x?
16.
Yeah, 16 over x plus 4x minus 16 equals 0. This should remind you of what we did in sequence and series. How did we solve this equation? What did we do? Multiply by x. Okay, calculator time, please. Tell me what the solutions are here. I think there might only be one.
Yeah, it's true.
And then if you put the 2 back in, it's a decimal because of the log. It's like minus 17.91, I hope. If you put the 2 back into this, 16 log 2 plus 8 minus 32 minus 5.
So basically the steps are find the derivative, then find the x by mod 53, and then
If it's a quadratic, of course, yeah.
yeah,
In other words, find the x, yeah.
yeah, and then sub in x.
Yep. And that's it. Not as difficult as earlier today. Right? A little bit easier. Let's plot this. So, oh, come on. There we go. Right, can somebody call out this one for me? It's y equals
And then x
log x to the power of 16
minus 2x squared
plus 2x squared.
minus 16x
Yep.
minus 5.
Okay, let's see if this works. Reset and draw. Okay, this must be really large then. Oh, freaky. What was our answer?
2.
X was exactly 2? Okay.
It's supposed to be minus 20.
Okay, well I'm not worried about the y right now, just the x. What was the x?
2.
2, okay. Yeah, that is where the slope of the tangent line is 0, because you can see how it's flat here. Maybe I'll zoom in a bit here.
No, why? Because y is
No, I'm
minus
saying
17.
something's wrong with my calculation.
Yes. Chill. It's minus 17 point.
9.
Yeah, okay, that's fine. That's what I wrote down, isn't it?
Yeah.
Yeah, okay, so it's all cool. You did press the LM button, didn't you?
Mm.
All right.
Yes.
Look up here. Let me just center on this cross, and let me zoom in a bit. Too much. It's hard to see, but do you see how the line levels out here? So if you imagine a tangent line here, it'd be lying flat. Whereas here, the slope would be what? Positive or negative? Positive. What about here? No? Positive because it's increasing. And what about here? Negative. Now it looks like there's a point down here that could be a minimum point, right? So let's try and zoom down to it. It's still further down, right? Now you can't actually see what's happening here, but this actually goes all the way down to infinity. So the graph has no value when x is 0. Why might this graph have no value when x is 0? Well, look at the original question number 3. Why would x equal 0 be a problem?
Because log is like that.
Log 0 is a problem. But look at this graph. I said for log you can't do negatives, right? But there's a negative there. Why? What happened? Well, look at the log. It's not log x. What is it? X power
16.
16.
Regardless of whether it's a negative.
Exactly. X power 16 is always positive because of the power 16. You know? Because think about it. Look. X power 16 equals x power 8 squared. And if something is squared, then it's positive. So then log x power 16 is good, except for when x equals 0. And that's why it's broken here. This break-in here you don't need to know for the exam. For the exam, you don't even need to draw this graph. I just want you to appreciate what this point represents. It represents the part of the graph that goes flat, where the slope of the tangent is 0. Yes? We're all cool? Great. So, whoa, yeah, going back, don't worry. Right, so let me tell you which ones to do. So circle these, please. I did number 1, 2, and 3, didn't I?
Yeah.
So let's see, do 4, 6, 7, 9, 4, 6, 7, 9, and then 26, 27, 29. 26, 27, 29. Did you get all of those? Yes? Alright, you can start them now for a few minutes. 5 minutes.
Yeah, we'll try. Sorry, Mr. Stevens. What's the difference between when we say turning point or
Absolutely nothing. I wanted to include as much vocabulary that means the same thing. So, guys, if you look at the questions, if you look at the questions, you notice how my vocabulary is quite different. But they all mean the same thing. Turn-in, critical, extreme, stationary, max-min, vertex. They all mean the same thing when the derivative equals 0. Okay? Alright, start those now.
What's W and X?
Did you need to write those down still? No? Okay.